going to see. So at the beginning of when we started talking about angles and arcs together, one of the things I did is up on the active board, I drew a bunch of circles with their angles. I had one circle like this, and then I drew the angle there. I drew another circle, put the angle there. I drew another circle, put the angle here. Had another one, the angle was there. And then today I'm going to add, there's also the situation where I have an angle looking like this. And I told you that when it comes to this chapter, the difficulty is not necessarily the individual problems, it's the fact that they get all mixed together. So, I pointed out that when it comes to working with angles and arcs, you needed to pay attention to what kind of angle it was. If the angle is on the center of the circle, what kind of angle is it? It's at the center. Only two types of angles we've talked about so far with circles. One of them's inscribed. The other one starts with a C.
Circumscribed.
Nope, that's circles. Nope. Central.
I wasn't even here.
Central. The ones that are at the center are central angles. So we had our central angles. We have our inscribed angles that are on the edge. We have these angles that are inside but not on the edge. But then we have angles outside and angles on the edge but partially going outside of the circle. We've talked about the central angles and how the angle and the arc have the same measure. We've talked about the inscribed angles, where the angle is half the measure of the arc. These ones, yeah, we don't really deal with those a whole lot. These are the two main ones that we're adding today. Okay, technically we're going to deal with those, but the picture is going to look like this, where it's going to have the additional angle marks in there. So these three pictures we're adding to what our angles look like. So when it comes to this chapter, as I've mentioned time and time again, and you're going to hear me mention time and time again, when it comes to these problems, the challenge is making sure you're using the right theorem. To get the right theorem, you match the picture. So 10.5 starts on page 15 of your notes packet. The first theorem we're introducing today is the tangent and intersected chord theorem. It states that if a tangent and a chord intersect at a point on the circle, what's a tangent? A line that intersects a circle at only one point, so this is our tangent. What's a chord?
A segment that goes on, that has 2 points on the circle.
A segment that goes from one point on a circle to another point on a circle, so that's our chord. If a tangent and chord intersect at the point on the circle, in other words, at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So that means the measure of angle 1 is equal to 1/2. Now angle 1, this angle has an intercepted arc right here. What is the name of that arc? BA or AB. 1/2 the measure of AB. We also end up with angle 2 in this picture. And angle 2, that angle, has this as an intercepted arc. What's the name of that arc? ACB or BCA. So essentially, we don't need necessarily both of those formulas because they work the exact same way. It's just telling you that an angle is half the measure of its corresponding arc, but in all technicality, when you do this, you end up with two angles, hence two different formulas, but they're doing the same thing. So, the big thing throughout this chapter is matching up the pictures. Does a picture like this one look like a picture like that one?
Yeah.
Tangent line, chord, angles and arcs. That's why we use these ones together. They've got the same general setup. Okay, it says line M is tangent to the circle. Find the indicated measure. Now, in all actuality, M got deleted from a couple of these, but those are all considered line M, those tangent lines. Okay, find the indicated measure, measure of angle 1. According to the formula, the measure of the angle, in this case angle 1, is equal to 1/2 its intercepted arc. Is the 130 the correct arc to go with angle 1?
Yeah.
Yeah, because it's the arc on the same side as the chord. So it's 1/2 of 130. What's half of 130?
That's about
65 degrees, indeed. Okay, problem B gives me a same style picture. So I'm using that theorem again that says the angle is 1/2 the measure of its corresponding arc. So I've got this 125 degree angle and I am looking for arc KL. Are the 125 degree angle and the arc KL the correct corresponding pair? No. Here's where I've got a couple of options on how to do it. Option 1. This angle and this angle are a linear pair. And linear pairs are supplementary, meaning they add up to what? 180. So, if this is a 125 degree angle, that means the other angle is 55.
yes.
So this would be a 55 degree angle. Is the 55 degree angle the right arc or the right angle to go with that arc? Yes, and then you could say the angle, 55, equals 1/2 the measure of the arc we wanted, which was arc KL. And how do we get rid of that 1/2? Multiply by 2. Measure of KL would be 110 degrees. Now that's one option on how to solve this problem. Option 2. The other option on how we could have approached this problem is we could have found this arc first. To find that arc first, we're still using this formula. The angle, 125, equals 1/2 the measure of its corresponding arc, and its corresponding arc was not KL, but KJL. Multiplied by 2, and we would have found that the measure of KJL is equal to 250 degrees. It's not the answer I wanted, but if If I know this arc is 250, how could I have found the other one?
360 minus 250.
Arcs of a circle add up to 360 degrees. These two arcs together make the full circle. So 360 minus the 250?
Okay.
110. Either way, do we get the same answer?
Yeah.
Yeah. You don't have to do it both ways. You just have to choose whichever way works best for you and which way works best for the situation, because sometimes there's going to be one of those options that's easier than doing the other. Particularly when there's expressions involved. Okay, we're solving for x on these next two. Measure of the angle is 1/2 the measure of its corresponding intersected arc, because this picture looks like the picture at the beginning again. This angle is 4x plus 11. This arc is 70 degrees. Are those the correct corresponding ones? Are they on the same side of the chord? Yes. This angle goes with that arc. They're on the same side of that chord. In all actuality, it's drawn as a ray, but we are just focusing in on the chord piece. So they are the correct corresponding ones, which means I can plug into my formula. In my formula, does the angle or the arc go first? Angle goes first. Make sure you're plugging the angle in alone. 4x plus 11 was the angle, equals 1/2. And the arc was 70. If I want to solve this, what's the first thing I should do?
Times 1/2 by 70.
Half of 70. 4x plus 11 equals 35. Subtract 11. Y'all know the math from here. 35 minus 11 is 24. Divide by 4 and x is 6. Is that what I was solving for?
Yes.
Yes. Problem D. Here's my angle. Here's the arc I know. Are those the correct corresponding angle and arc? Mm-mm. They're on opposite sides of the chord. This angle goes with this arc. That angle goes with that arc. So, here's where I have to bring one of these two options into play. One of those two options is going to be easier than the other. Actually, this one's not terrible either way. Would you rather start with the linear pair to get the correct angle, or to find the incorrect arc and then move it into the correct arc?
Option 2.
Define the option.
I personally think option 1 is easier on this one.
Oh.
Because if you go through and start with option 2, which is not terrible, you'd find the second arc as a number, and then because this arc has the variable involved in it, I'd have to create another separate equation in order to solve for x. Versus on this problem, I could just straight up subtract to get to the correct arc. So generally, which option I do is depending on where the variable is. If the variable's on the arc, I modify the angle first. If the variable was on the angle, I would modify the arc first. Either way, you should get the same answer. If you prefer option 2, try out option 2 while I go through and do option 1. Okay. These two angles are a linear pair, therefore they should add up to 180. 180 minus the 47 is? Y'all might want to grab your calculators if you don't have them.
Are all of them linear pairs?
When you're working with this picture, you will always have a linear pair. Because you're always going to have that and that coming out of it. So, this is a 133-degree angle. Now, I can plug into my formula. The formula says the angle equals 1/2 the arc. The angle has to go first. 133 goes first, equals 1/2 times the measure of the arc. 88x plus 2. If I want to solve for x and I have an equation that looks like that, what do I have to do first?
Eliminate that first.
Yes, but there are two ways to do it.
Well, I could either like multiply or.
One option is distribute. The other option is to multiply both sides by 2. When this side's just a number, honestly, I would do that way. But for some of you, it's automatically a distribute thing. Either way, you'll get the same thing. If I chose to distribute, I'd end up with 133 equals 44x plus 1. If I did the multiply by 2, this side it cancels out. On this side, I have to make sure I multiply everything over here. In this case, it's only one thing. I end up with 266 equals 88x plus 2. Now, they look different, but in the end, these two should solve to get you the same x value. This one's smaller numbers, so I'm just going to continue this one. 132 equals 44x. Divide by 44, and x is 3. If I had done this one, guess what? X would have been 3. So, if you see a tangent and a chord intersecting at the point of tangency, in other words, you see a picture that looks like this, if you're working with angles and arcs, these are the formulas you're using. Now, on the very bottom of this page, it talks about the fact that when you have secants intersecting, they can intersect in a number of different places. They can intersect on the circle, creating an inscribed angle. They can intersect in the circle or outside of the circle. These two situations we haven't talked about yet. On the top of the next page is what happens if they intersect inside the circle. Now, these can be secants or they can be chords. The theorem itself mentions chords, but the process is the exact same if these were secants, because if I extend these indefinitely, making them all secant lines, did that change the angles or the arcs? No, it just changed the segments into lines, which didn't change anything. So they could be secants in this picture as well. Anyway, it says, if two chords intersect inside of the circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay. So, breaking this down, the measure of each angle. So let's start with angle 1. Is equal to 1/2 the sum. A sum is addition. And if you're going to do half of an addition, you need parentheses. Otherwise, it will only do half of the first part. The sum of the measures of the arcs intersected by the angle and its vertical angle. Okay. Angle 1 has that for an intercepted arc. So the measure of CD plus its vertical angle's intercepted arc as well. vertical angle is that one. That angle's intercepted arc is arc AB. Now, in all technicality, the next formula I'm going to give you is for angle 2, but it's the exact same setup. The only difference is now it's that angle instead of that one. Measure of angle 2 is 1/2. The measure of its arc is arc BC. Plus, the vertical angle's arc is, I'll try not to drop it again, AD. Either way, these two formulas are both the same setup. One of the inside angles, the two arcs, one inscribed and the one across from it. Inside angle, it's inscribed, and the one across from it are the correct arcs. So, now, again, you're matching up pictures. You need a picture with this where you've got a cross going on inside and it's talking about angles and arcs. Cross inside, angles, arcs. That's the right setup. That's the picture that looks like this. Is that the correct angle to go with these arcs? Yes. So, I work with the formula. Formula, does it start with an angle or an arc? Angle. In this case, the angle we know to be x equals 1/2. Am I adding the arcs or subtracting the arcs? Adding. 130 plus 156. Looking to solve for the value of the variable, so solve for x. I could distribute the 1/2, but what's going to be easier? Nope, because that's going to get a number in front of x. PEMDAS. Add the parentheses. Those are like terms. Put them together. 286. Then do half of that. Half of 286 is 143. If all the numbers are on the same side, just do PEMDAS. Problem B. Two lines crossing inside the circle. I'm talking about angles and arcs. That's the formula I want. That angle go with those two arcs? No. But aren't those two a linear pair? Linear pairs are still supplementary. Meaning they add up to what? 180. So if I take 180 minus the wrong angle, which is the 102-degree angle, I get 78 right here. I could have technically done this one too, which is also 78. Does the 78-degree angle go with those two arcs? Yeah, now we got the matching ones. Angle equals 1/2 the arcs added together, 95 and y. To solve, first thing I need to do is get rid of the 1/2. I can distribute or I can multiply by 2. When this side is just a plain number, multiplying by 2 tends to be easier. 78 times 2 is 150. 56 equals 95 plus y. Subtract 95. Y is 61. Be careful, sometimes they might ask you to plug it back in. This one they wouldn't, just because it's Y. But keep an eye on that. Try out the last one on this page on your own.
E is not a variable. E is just indicating that that's the name of that point. Those are vertical angles, but there's just different points on there. And that shouldn't be a measured number. Okay. True. But that angle, should we go with those two arcs?
got such a big gap in your thing, it's hard to see. Good. I'm not looking for that, I'm looking for that.
I knew that.
Okay, plus, what's the other half? Yeah, 29.
Okay. Does that angle go with those two arcs in this formula? Yes. In the formula, does it start with the angle of the arc? Angle. So in this case, the number 107 equals, don't forget the 1/2. Arcs added together. 61 and 29 plus x plus 8. I don't care which order you add them in. It doesn't make a difference. Combine like terms here. Which one of those go together first? 61 and 8. I got the 29x and 69. To get rid of that 1/2, the easiest way to do it is to... You could distribute. I find it easier to do this, but if you distributed, it would work out as well. But since this is just a number, I do this. 214 equals 29x plus 69. Continue to go down and solve, and what will x end up being? 5. Be careful, sometimes it'll say it wants the measure of arc CD. In this case it didn't, but if I wanted the measure of arc CD, I'd plug 5 back in. Okay, now, there's that last situation on where the angle can end up. And that is that the angle can end up outside of the circle. Now, if the angle ends up outside the circle, it could be made by tangents, by secants, or a mixture of a tangent and a secant. This is one theorem that covers these 3 pictures, because those 3 pictures essentially all have the same formula. It's slightly different based on just kind of what you can see in the picture, but it's the same idea. If a tangent and a secant, or 2 tangents or 2 secants intersect outside the circle, then the measure of the angle, this first one would be measure of angle 1. Second one would be measure of angle 2. We'll come back to the third one. Equals 1/2 the difference. What is a difference?
Something different.
Subtraction. In math, difference is subtraction. But if you're going to do half a difference, you need parentheses again. The difference of the measures of the intercepted arcs. Specifically, when I have angle 1 right here, the intercepted arcs are this one and this one. Now I'm going to subtract those 2 arcs. I want angles to be positive. Does it make more sense to do little minus big or big minus little? Big minus little. Which one looks bigger? AC or BC? BC. In fact, it will always be the one furthest away from the angle that will be the bigger one. In this case, since the angle's on the left, the biggest one's on the right. So it's measure of BC minus measure of AC. Big minus little. Same idea goes here. My intercepted arcs are PR, and the other one is PQR. The bigger of the 2 is going to be PQR. So measure of PQR minus measure of PR. The last one works the exact same way. The only reason I didn't write it is because I want you to think about it a little bit. What do I start with, an angle or an arc? It's an angle. Have you noticed that most of these formulas start with an angle?
Yeah.
There's a reason. The angle equals, according to the thing, 1/2. In parentheses, the difference of the 2 arcs. One of my arcs is right here at WZ. One of them is XY. Which one should go first? XY, because it's the bigger. Was it plus or minus in this formula? Difference, minus. So, 3 different pictures, but they're all using what is essentially the same formula. Angle equals 1/2 big intercepted arc minus little intercepted arc. So, this picture, it's got a tangent and a secant. It's got an angle outside the circle. It's got 2 intercepted arc. That one is in between the 2 rays of the angle, and this one is between the 2 rays of the angle. Are those the correct rays to go into the formulas? Sorry, correct arcs is what I meant to say. Yes. Does my formula start with an angle or an arc?
Angle.
Starts with an angle, and in this case the angle is x equals 1/2. 2 arcs are the 76 and the 178. Which one goes first?
178.
178. It's the bigger, it's the one further away from the angle. And here's one of the biggest mistakes that people make.
They put a plus.
They put a plus. What should be here?
Minus.
Minus. Do you notice that all the numbers are on the same side of the equation?
Yeah.
So PEMDAS,
Yeah.
178 minus 76,
102.
102. Half of 102 is indeed 51. If you had distributed the 1/2, you should have gotten the same thing. Question B. I got a 35-degree angle outside the circle. Intercepted arcs are this one and this one. Those the correct arcs? I see some people nodding. Okay. Start with what? 100x or 35? 35, because it's the angle. Equals. The other biggest mistake that people make is they forget this next piece, which is always a 1/2. Parentheses. What minus what? 100 minus x. The 100 went first because it's the bigger arc. I know it's the bigger arc because it's furthest away from the angle. Either distribute the 1/2 or multiply both sides by 2. I don't care which way you do it. Since this is just a number, I tend to multiply by 2. 70 equals 100 minus x. Subtract the 100 because it's positive. Negative 30 equals negative x. To get x alone, divide by a negative. X is
30.
30. Be careful of your solving. A lot of people add the 100. It's the x that got minused. Okay, the last 2 problems show you some other things that cause some hiccups with people. So the last 2 are a little bit more challenging, but doing the same stuff. Now, before I go actually into it, this picture, do you notice an angle outside the circle?
Uh-huh.
It's talking about angles and arcs. Now, the theorems, if you look at their pictures, does this picture match one of those 3 pictures nicely?
Not nicely, but.
Perchance. Number 2.
Matches number 2, but one of the big hiccups that people come up with is that these lines keep going. In the theorem, they technically do. But if I stop the lines, does that change the arcs that I'm looking at? No, doesn't change the arcs, doesn't change the angles. Don't get caught up on if the lines continue to go forever or not when it comes to these theorems. Does it make a difference on if it's a segment or a line? Yes. Will it change the arcs or the angles? No. Okay. So, in the formulas, angles go first. What's the angle in this picture? 7x plus 4. Equals 1/2 arc minus arc. How many arcs do I know? 1. Can I solve it if I don't know the other one?
Yeah.
Yes, in this case I can because I know enough information. Here's the information I know. This is the arc I was given. The arc that I need for my formula to work is the arc that does this. Do you notice that they together make a full circle? If they make a full circle together, what do you know about their measures? They add up to 360. If they don't make a full circle together, they do not add up to 360. These two, the x and the 100, do not add up to 360. Because there's these parts out here. But if the two arcs make the full circle together, they do add up to 360. So 360 minus the 134 will give me this missing arc. 226. Okay, I'm going to subtract the arcs. Do I do 134 or 226 first? 226. The bigger one, which is the one further away from the angle. If I want to get rid of that 1/2, yes, I can multiply both sides by 2. But if this side's all numbers, I would just PEMDAS that side. 226 minus 134 is 92. Half of 92 is 46. Subtract 4. 7x equals 42. Divide by 7 and x is 6. Okay, final problem. The one with the biggest hiccups. I've got an angle outside of a circle. I've got these two arcs. Are those the correct arcs for my picture? Yes, they are the correct arcs. They're both the intercepted arcs for this setup. So, formula starts with the angle. 71x minus 1 equals 1/2 measure of the big arc minus the measure of the smaller of the two arcs. The biggest problem comes with the setup. Comes with making this formula, because I'm going to tell you right now this is technically not right. You don't need to erase it. There's just one tiny little problem. I'm supposed to do the bigger of the two arcs minus the smaller of the two arcs. But what I wrote was 211 minus 70x plus 1. Is the 70x the 70x is the only thing I subtracted here. Is the 70x the smaller of the two arcs? By itself? No. I didn't subtract the plus 1. When you subtract a binomial, in other words, when you subtract something that's got more than one term, you technically need to put it in parentheses. that way, you distribute this negative to subtract both pieces. 71x minus 1 equals 1/2. I still haven't touched all of this stuff. I'm subtracting the 70x. I'm subtracting the positive 1. Now I combine like terms and solve. From here, people don't tend to have a problem. People tend to forget those parentheses, and if you forget those parentheses, it's wrong. I combine my like terms. 211 minus 1 is 210. When it comes to this situation, to get rid of that 1/2, multiplying by 2, make sure you multiply both of these. Distributing 1/2, make sure you multiply both of them by 1/2. It doesn't matter which way, neither is easier here. In that case, I tend to just distribute the 1/2. Gives me smaller numbers. Half of 210 is 105. Half of negative 70x is negative 35x. Add 35x. 106x minus 1 equals 105. Add the 1. 106x equals 106. Making x 1. The big issue is those parentheses. You've got to be careful of that. Remember how last week was all book assignments? This week's mostly worksheets.
Whoop, whoop.
I'm looking at tomorrow's stuff. Yeah, we interjected a